Okay, this is now the second part of the electrolysis video. As you can see, we are now going to be looking at predicting the products formed, and we may then start to look at the reduction side of things in this video. If not, we'll look at it potentially in another video. So, just a reminder, this is the electrolysis setup in the top left corner. We have the cathode, which is the negative electrode, and anode, which is the positive electrode. The reason why the ions or the elements move to these different electrodes is because they are electrically charged. So electrically charged means they are positive or they are negative. So a negative ion will move to the anode and the positive ion will move to the cathode. You need to remember which one is the positive, which is the negative, which is why we have this way of remembering it. Panic. Positive anode, negative is cathode. You need to remember that so you know which electrode the ions will move to. So just a very quick reminder, this is an example of electrolysis, zinc chloride. So in this example here, our zinc, which is positive, is going to move to the negative cathode, and the chlorine ions, which are negative, are going to move to the positive anode. The reason why these will move is because they are in the molten state. Remember that they are in the molten state, which means a liquid state. So therefore the ions are free to move and can carry the charge. So the ions must be in a molten state so they are free to move and can carry charge. If they can't carry charge, then they are not going to be attracted or move. If they're not free to move, then they're not going to move, obviously. So this is just a very quick reminder of the electrolysis setup. We have a positive anode, a negative cathode, and our ions will move to their opposite charge. So the zinc is positive, so it moves to the negative, and the chlorine is negative, and it moves to the positive because opposites attract. If you're not quite understanding that, please either go back to the previous video, get in touch with me, or look online, BBC Bite Size, or look on YouTube, free science lessons, etc. There's lots out there to help you understand that. But what we're going to do now is take a step forward through the practical and look at something slightly different. So for instance, in the last slide, I said that we had zinc chloride and you get zinc and you get chlorine. If you have a sodium chloride, you will not get sodium. You'll get chlorine, but you won't get sodium. So the name of the compound doesn't always tell you exactly what you're going to get at the end of the electrolysis. My sentence here on the screen says, in some electrolysis experiments, hydrogen gas is produced. So let's have a look at that. This is the reactivity series. If I have a metal which is less reactive than hydrogen, I will have that metal come out during electrolysis. So if I try to electrolyze something with copper in, copper will be released from the experiment. However, if I try to electrolyze a metal that is higher than hydrogen in the reactivity series, so for instance, if I try to electrolyze something with zinc in it, I won't get zinc. So my example previous is where zinc chloride, I wouldn't get zinc. Why? Because the zinc is higher than hydrogen. So in that case, you get the gas hydrogen given off. So if the metal is lower than hydrogen in the reactivity series, you will get the metal given off. If the metal is higher than hydrogen, you will get hydrogen gas. So you can see it's reasonably difficult to get a metal out. So some examples here. Sodium chloride. We're not looking at this part of the compound. Okay, we're only looking at the first bit. 1, 2, 3, and then 4. So in number 1, we've got sodium chloride. So am I going to get sodium out? The metal is always the first part of the compound. Am I going to get sodium out? Look at where hydrogen is, which is here. look at where sodium is, it's right up here. It's above hydrogen. So therefore, no, I'm going to get hydrogen released there. Let's look at magnesium. Where's hydrogen? Hydrogen's here. Where's magnesium? Magnesium is again well above it up here. So that one, again, I will get hydrogen given off. Copper. Where's hydrogen? Copper is below hydrogen, so I will get copper. And the final one is tin. Look at hydrogen again, hydrogen's here, tin's just above hydrogen, so you're still going to get hydrogen given off. Now, that was looking at the first part of the compound, which is the metal. The second part of the compound tells you what you're going to get off as a gas. So, sometimes you'll get oxygen gas given off. If you look at a compound and it has a halogen, then the halogen will be produced. What is a halogen? The halogens are these elements. They're in group 7. Fluorine, chlorine, bromine and iodine. They are halogens. So if a halogen is in the compound, that halogen will be produced. If there's no halogen, you will get oxygen. So let's look at these examples. And again, this time we're not looking at the first part of the compound. We know that they're the metals. We are not looking at them. We're ignoring them for this part. So I have chloride. Is chloride a halogen? Yes, it's chlorine. It's chlorine in its ion form. So it's a chloride, which means it's a halogen, which means I will get chlorine. Sulfate. Is sulfate a halogen? Fluorine, chlorine, bromine, iodine. There's no sulfur in there, so therefore I will get oxygen gas because sulfate or sulfur is not in the halogen group. Bromide. Well, bromide is the ion form of bromine. So therefore, yes, I have a halogen, which means that I will get bromine. If that said fluoride, I would get fluorine. Carbonate. Carbonate is not in the halogen group, so therefore I must get oxygen. It's either the halogen, it's either a group 7 element, one of these 4, or oxygen. Again, if you're not sure about that, look into it a little bit more, contact me, we can talk about it. So, what I would like you to do is answer these questions. Name the halogens. What would the products be if the following were electrolyzed? Explain in full detail with reasons how an ionic compound is electrolyzed. Remember the state. And the last one, during electrolysis, is the metal always produced. And then you've got a couple of exam questions there. So pause the video, we'll then go through them. Okay, so name the halogens: fluorine, chlorine, bromine, iodine. You might put acetine in there. The group 7 elements on the periodic table. What would be the products of the following compounds if they were electrolyzed? So sodium is higher than hydrogen, so you're going to get hydrogen here. Chlorine is a halogen, so you get hydrogen and chlorine. What would be at the anode? What would be the cathode? Anode is positive, so the chlorine goes to the anode, the hydrogen will go to the cathode. Magnesium, higher than hydrogen, so you're going to get hydrogen and you're going to get oxygen because oxide is not a group 7 element. Again, anode is positive, so oxygen, which is negative, goes to the anode. Magnesium, positive, goes to the cathode. If you're not understanding which one goes to which side, we are going to go through that shortly. Lithium, again, higher than hydrogen, so you're going to get hydrogen. Sulfate, not a group 7, not a halogen, so you're going to get oxygen. Sodium, we know it's already higher. Phosphate, no, that's not a group 7, so you're going to get oxygen. Aluminium, also higher. Chloride is. So hopefully, oh sorry, not chlor, that's not oxygen, that's chlorine, sorry, my fault. So hopefully we've done okay there. Again, if you've got them all wrong, you're really unsure, go back to my description earlier or contact me. Question 3, explain in full detail with reasons how an ionic compound is electrolyzed. So this is our method. So the first thing you need to be stating is that an ionic compound needs to be in a molten state. That's your first mark. It needs to be in a molten state. Why? So the ions are free to move and can carry the charge. So 3 marks there for saying ionic compound must be in a molten state so that ions are free to move and can carry the charge. 3 marks. Your next thing would be you obviously put the solution into a beaker, turn it up, turn on a power supply. The positive ion will be attracted to the cathode, the negative ion will be attracted to the anode. So I'll go through it one more time. The ionic compound must be in a molten state, 1 mark. So the ions are free to move, 2nd mark, and can carry the charge, the 3rd mark. The power supply is turned on, 4th mark. Your positive ions attracted to the cathode, 5th mark. Negative ions are attracted to the anode, 6th mark. That's it. During electrolysis, is the metal always produced? No, it's not. Why? Because if the metal is more reactive in the reactivity series than hydrogen, you have hydrogen produced. The example could be sodium, just above. Sodium is higher than hydrogen in the reactivity series, therefore you get hydrogen. A couple of exam questions. Explain how chlorine gas is produced at the positive electrode. It's just what we've been saying in the question so far. The chlorine is attracted to the positive, it then bubbles out. And we're going to go into that in a little bit more detail in a minute, but as long as you've got that it's attracted to the positive, that'll do for now. Why is hydrogen gas produced at the negative electrode? It's exactly what we've been talking about, because sodium is higher than hydrogen in the reactivity series, so therefore hydrogen is given off. So this is where we're going to step it on a little bit more. I've been talking about ions, I've been talking about attraction, and this is where we're going to go into it now in that little bit more detail. So look at these atoms here in front of us. All these atoms want to be stable. They do it by having a full outer shell of electrons. If you've forgotten about shells and electrons, please go back and look at that on BBC Bite Size or in your notes. So they all want to be stable, and all these 3 are metals. All these 3 are metals, and in order to become stable, which means they want to get a full outer shell, these 3 will all lose their electrons. So sodium will lose its outer electron, it's only got 1. Aluminium has 1, 2, 3, so it'll lose all 3, and magnesium has 2, so it'll lose its 2. So now that sodium's lost 1 electron, what charge does it become? So remember, electrons are a negative charge. So if you lose 1 negative charge, you're going to become positive 1. Aluminium has lost 3. So what's it going to become? It's going to become positive 3. And magnesium has lost 2 negative charges, so it's going to become positive 2. Hopefully it makes a bit of sense. Electrons are negative charge. If you lose 1 negative charge, you're going to become positive. And that's how these 3 ions are formed. So what about the non-metals? So here we have oxygen on the left, and we have fluorine on the right. Now these are non-metals. So non-metals gain electrons. How many electrons does oxygen need to have a full outer shell? It's got 6. Well, it's going to need 2 more. Fluorine has got 7, so it needs, one more. So oxygen becomes -2, and fluorine becomes -1. You don't need to write the 1 in when you're writing -1. If you do, it doesn't matter too much, but technically speaking, you won't write it in. So they are what we call our ions. If it's got a plus charge or a negative charge, it is an ion. It means it is either lost or gained electrons. An ion is something that has lost or gained electrons. This is the oxygen ion, 2-, and the fluorine ion, F-. So we are starting to move on more and more higher level things. So if you're not quite keeping up, remember to go back, go through it again, come back. So what we're going to be looking at here is what happens during electrolysis. This is the anode on the left hand side because it's positive, and this is our cathode on the right hand side because it is negative. So imagine the cathode is full of electrons. This cathode here is absolutely full of electrons. The anode, imagine doesn't really have electrons. They've all been taken away. So during electrolysis, we know already that this negative chlorine is going to move to the anode because the anode is positive and opposites attract, and this positive sodium is going to be attracted to the negative cathode. We know that from earlier on. But then what happens? Well, as my positive moves to the negative and my negative moves to the positive, this is what happens. As the positive ion reaches the cathode, it gains one of these electrons. It gains one of these electrons here and turns back into sodium. It's no longer an ion. It's an ion at the start with a positive charge. It gains an electron because it's now moved to the cathode, and it turns back into sodium. So I'll just go through it one more time in case you were a little bit lost there. Sodium ion, remember this sodium ion has lost an electron. It lost an electron at the start of the electrolysis. This is now towards the end of electrolysis, so the sodium ion moves to the cathode, which is full of electrons. So the sodium ion then gains an electron and turns back into sodium. So it started out as a sodium element. It turned into an ion when it lost an electron, and it's now gained an electron again and turned back into the sodium element. Chlorine does exactly the same thing. The chlorine ion, which is negative, moves to the positive anode, and this time the chlorine loses an electron and turns back into chlorine. Now you'll notice it says Cl2. It says Cl2 because chlorine always exists as Cl2. So you've got to make sure it ends as Cl2, and therefore you've got to balance your equation. Now I'm not going to go into that in too much detail right now, but that's why there's 2's there, because you've got to balance your charges. I've got 2 chlorines here, so I had to put a big 2 here, minus charge. I've then got to have 2 minus electrons. But I don't want you to worry about too much now. I want you to think about what happens to the ions in electrolysis. What is going on here? So here, my chlorine, which is negative, moves to my positive anode and loses an electron. Okay, so a positive ion will gain electrons when it moves to the cathode, and a negative ion will lose electrons. That is the main part you need to know, those 2 blue sentences, so I would write them down. A positive ion will gain electrons at the cathode, and a negative ion will lose electrons at the anode. Okay, so we're going to look at the balancing. All I want you to do now is have a look at these 3 exam questions here. So 1 here, 1 here, and 1 here. If you can pause the video, answer them, that'll be the end of this session. Okay, so you've hoped you read through it, and hopefully we've got majority of the answers here. Explain why electrolysis will not take place in the apparatus shown in figure 1. You need to look at all the figure and think, well, why is it not going to work? There's a power supply, good. We've got a positive and a negative, that's fine. We've got our electrodes. We've got the solid zinc chloride. There's the issue, solid. So explain why electrolysis will not take place, because the zinc chloride is solid, so that ions are not free to move. 2 marks. So because the zinc chloride is solid, so that ions are not free to move. Or if you said the zinc chloride needs to be molten so that ions are free to move, it's the same way around. Predict the product at the positive electrode in electrolysis of sodium chloride. So which is going to go to the positive? So in sodium chloride, that one will be chlorine. I'll try and write it out as neat as I can, but my writing's the worst of the better times. Chlorine. Next one, copper sulfate. Well, you're looking at this. Sulfate is not a halogen, so you're going to get oxygen. And finally, explain why magnesium chloride must be molten or dissolved in water to be electrolyzed. So again, it's just a very similar question to the first one. It must be molten so that ions are free to move and can carry the charge. Very important question. Explain why magnesium chloride must be molten or dissolved so that ions are free to move and they can carry the charge. So that's the end of this video. What I'd like you to do is answer the questions that are going to put on Educate. If you've got lost anything in this video, please go to BBC Bite Size or go into Free Sound Lessons on YouTube, research it a bit more. Or if you would like to contact me, please do. You all have my email address now. Hopefully it's gone okay. But like I say, feel free to contact me if you need. Please now go and complete Educate 1 to complete your learning on the electrolysis.